Ted, thank you again for having me present. We're gonna just cover for folks who are not familiar with payments, what the history of payments is and the innovations that have happened, and we'll cover what ISO 20022 is, what it is, why is it different, what's the impact. Um, we'll, we'll talk about the kind of the technology that we use, but why we're excited by this new standard and what it promises for the whole payments and basically global commerce. Let me again. I'll put a plug in for the clearinghouse. We're a small company. You probably never heard of us, but we've been around since 1853. We've been doing payments since then, when banks used to get together on a street corner and exchange IOUs. So this is a very old company. It's been owned by banks from the very beginning, and we've evolved over the 160 years, providing payment solutions to the banks. So we're owned by banks. You see the logos of the 22 banks below, but we also have customers. We have thousands of banks as customers for our different payment systems. We move like you said in the introduction, about $2 trillion a day in payments in U.S. dollars from one bank to another. So when you're paying your mortgage payment, or you're doing a Venmo for there's about a 50% chance, if it's a wire or ACH, that it's routing through the clearinghouse. The other half of wire and ACH will go through the Fed. So between us, we do. It's kind of mind-boggling, these numbers. I mean, it sounds kind of glib, say $2 trillion a day, but it's you add up to $2 quadrillion a year of transactions. You have to get every single payment right. There's no backing out. These are interbank transfers, and they have to be final. So no mistakes on these transactions. And what what I'm going to talk about today is a big shift in how payments are being made. For all of history, payments were done in a proprietary ways, and we're now at the brink of a global standard for all payments. And the United States is now getting on board. So I won't go through the history of payments, but the innovation that has happened in the payment industry has been extremely rapid in the last few years, as we've moved to from simple moving checks and paper between banks to more digital commerce, more global. We have challenges doing global transactions because there's a lot of legal, regulatory issues in making sure that you trust the people that are involved in a payment transaction. A lot of payments that move across the U.S. dollar is the gold standard for payments in the world. It is the number one currency. So any large payments that are being made almost always are going to be in the U.S. dollar. Try to speak more clearly. So I just listing here some of the disruptions that have happened in the payments industry. So between when the first wire payments were made, when Western Union, when the first telegraphs were actually created, those were ways to now transfer money across distances. When we went to the cell phone and to be able to make transactions, payments have been just more and more rapidly changing the nature of how we make a payment, whether it's as a consumer or as a corporate, using paying for supplies, being able to sell goods and services to other companies. So what is ISO 20022? Well, it's been around for about 15 years. It's an XML-based standard, and it replaces all the proprietary interbank messages that have been prevalent until now. So when we send a payment with the clearinghouse, we've had wire payments for the last 60 years. We've processed wire payments. We've used legacy mainframe applications, our banks would connect to us and they would use our format to move money. And between the banks, they would use their own proprietary formats. So each bank, the Federal Reserve had its own format. Banks in Europe, banks in Asia, all had their proprietary formats. So every step along the way, every hop between the banks, between the customer, the buyer, and the seller, every time money was moved, you had to take care of what that transformation of the data was. Now, ISO 20022 is a single global standard, a set of message formats, XML based, and as we'll see, it's a fairly complex, rich format that requires that all the information be transmitted with integrity and fidelity from the beginning of the transaction to the end. So there's no cutting corners here. Once it's in the ISO 20022 format, all that information has to be traveled. It's a legal requirement, especially cross-border, something called the travel rule in payments that makes sure that all the data is nothing is tampered with, nothing is changed along the way. The format is consistent. So this has been adopted primarily in Asia and Europe over the last, for many years, culminating in a major migration of many banks in Europe last year. And then April of this year, the clearinghouse moved all our wire business, all of our banks, to this new format. So that means that, again, $2 trillion a day moving across. In March of next year, the Federal Reserve will also be moving to the standard. It'll be the last major operator to adopt the standard. And then once after March, global dollar payments will all be using the ISO 20022 standard. So why did we need it? Well, the standard gives us a lot more flexibility. So you can imagine every proprietary format was built decades ago, very compact for processing, very little superfluous information. So a lot of data was potentially dropped as it was moved from systems to system. The ISO 20022 is much more verbose. It captures all dozens of parties to a transaction. In a typical large global payment, you'll have several banks involved on both the buyer and the seller side. So you may be transferring in a single payment billions of dollars between a Citibank account and a JP Morgan account, for instance. But before it came to that transaction, the customer may be using a small bank in Europe or Japan. There's a chain of banks typically before it finally gets from one account to the other account. So we call this correspondent banking. It's dominant in global payments, and the corresponding networks can be very significant. Because each of those banks is liable to make sure that the payment is effective, it's important that information stays consistent throughout. The failure rate in wire payments has historically been quite high. The compliance requirements are very high, so it's the most expensive type of payment you can make. If I write a check or if I transact with my Venmo, those are for small dollar amounts and they're very cheap payments, but they don't have a lot of compliance requirements around it. A global payment, when you're talking about billions of dollars crossing borders, there's an enormous amount of scrutiny and regulatory compliance, and the banks charge quite a bit of money. So if you've ever done a wire payment, you know it's significant. The payment, it's not, even though it's pennies for the digital transaction, for the electricity to be used to carry that transaction, it's a hefty fee to actually conduct a wire payment, and a lot of that is because of the friction and the compliance along the way. So again, the benefits of ISO are much richer data, easier compliance because the data is all the same across the banks, more resilient, provides a lot more availability to route the payments correctly. The data itself lends itself more to greater analytics how are my customers buying and selling for the bank's perspective. From the corporate perspective, they can understand their payments as well. They're not having to look at a variety of formats. One of the things we talk about in financial services is straight-through processing. Whenever something fails along the intermediaries, that costs money and that wastes time. So when a consumer is trying to buy something and move the money from the buyer to the seller, any hiccup along the way is dissatisfaction on both the buyer and the seller. So that ability to do straight-through processing when we have multiple banks along the way is really critical, and that's why this standard is so important. I mentioned analytics, not just what customer behavior, but also things like fraud. The significance of the opportunities for fraud throughout a payment transaction are high, and the more participants, the more possibilities that fraud is happening. If you don't have a global end-to-end view of those transactions, you don't necessarily see that ability to say who is the bad guy on a payment. After the payment has been made, there's also laws that may have been broken in that payment. So wire fraud is one of the most serious of financial crimes. Wire fraud requires us to look at every party of a transaction. If there's a bad person or a bad entity located in some geography, we need to be able to search that information and be able to support that. We ourselves, the clearinghouse, report that information to the Justice Department, to different courts, and we're required in some cases to perform those searches and be able to return all the payments that particular party has made. So our search systems have to be extremely robust, and the complexity of the ISO format, it's not a simple thing of just putting the data in a traditional database and doing a search. You have to look at all the nuances in the relationships between those entities. On the right-hand side, I have a tiny fragment of the ISO, like a sample message. In our proprietary format, before we moved to ISO 20022, we had basically a message format that was a few hundred bytes, maybe a kilobyte for a long message. In ISO 20022, the average messages is a magnitude larger. The number of entities that can be captured is far more complex. The agents for each of the transactions, the name and addresses. We have structured and unstructured data. In some cases, the ISO format allows unstructured data. Other areas, it requires structured information. So you may know the country and the city and the state and the building number, departments, all that, or you may not, depending on which party it is and what the rules are. So it's a very complex set of rules, which makes it challenging to validate an ISO message and makes it interesting to try to search for information. Again, it's a mixture of structured and unstructured data, so we need technology that can actually take that information and be able to present it with fidelity to our analysts, to our legal teams, to our operations folks. So it's a complex and rich format, which means it's also very flexible. So it's great for a lot of reasons, but it's also challenging for people who are used to seeing things in rows and columns in like a relational database or in a JSON message even. This is a very highly nested and challenging format. We also have to be able to track a payment no matter where it is in the cycle. So if a buyer in Japan is moving money to a seller in India, we need a kind of that UPS tracking ID, right? To make sure that payment, we know where it is, any point in time, has anything gone wrong with it. So there's new requirements to enforce to make sure that that unique identifier is available and we can have a status of that payment as it wends its way around the world. And again, I mentioned the travel rule. There is an obligation for all parties to make sure that the data is faithful to the original format, that there is no data loss. So again, if you can move this into traditional databases, but you're very much on the hook. If the format changes, the schema is slightly different, you have to test all those permutations. If you're trying to map the ISO message to a traditional table column relational database, you'll end up having thousands of columns. Most of the times that data is going to be empty because there are very few required elements as a percentage of the data, but there's a lot of optional data elements. So you end up having a very challenging if you're using traditional analytics. If your users are used to using SQL interfaces, for instance, and to access a relational database in the backend, they're going to have difficulty looking for all the places where that data might exist. At the clearinghouse, we spent several years getting ready for this transition. So on April 8th, earlier this year, the same day that we had the eclipse in North America, it was a very big deal for us. We had people who had been working on this project for over 3 years. The standard had been around for we had people working on the standard for more than 15 years, and we had our core processing here is a mainframe. Not the easiest way to adapt to a new standard and have that flexibility. So we geared up for a major architectural change. We did decide on a design pattern called Command Query Responsibility Separation, CQRS. The payments that come to us are real-time messages. We have a set of queues that our customers send payments to us, and we respond back with the appropriate response. So, is the payment valid? Has the payment been signed by the bank? Is it? Do we have proof that it's been digitally? It does come from that sender. We have a ton of validation rules to make sure that the payment, the schema, the XML schema is valid, and then the data is valid. But also additional business rules that have to be applied on that. So, from an architecture perspective, we have queues that where we communicate with our customers. We also have a ton of called the microservices or a ton of rules that are implemented to check the messages and to transform the messages, to do the accounting, make the payments, the ledger payments, and then send out the appropriate confirmations to both the sender and receiver of the payments. So that's our architecture. This is not that different from our legacy system, but it does require a lot of upfront processing of that message format. On the right-hand side here, you see the advantages that the new standard gives us. We now have the ability to take a look at any payment in rich amount of detail. We built our own with help from MarkLogic and professional services. We adopted a framework to be able to query that data for custom solutions for our legal folks, doing XML-based search, so not having to transform the data into some other format, but keeping it in native XML. We now have available APIs to be able to pull that data, and we are also looking at ways to expand the access. So for those who prefer a SQL interface, creating views, being able to have the data available in JSON for some consumers. We also have use cases where we'll be looking at risk and fraud from a network perspective. So graph analytics across the payments. You can imagine, if I'm a Bank of America, and I'm sending and receiving wire payments on behalf of my customers all day, I can only see the traffic that are emanating or coming to me as a bank. I know my customers. I can pretty much guarantee that they're not. I've gone through all my fraud screens, but I don't know the other customers that I'm sending and receiving money to. So that we can provide a lot of that information so that the banks who have invested enormous amounts in their fraud systems can now use this data in a standard format. And then finally, we're looking at AI and ML. We do a lot of internal liquidity risk analysis on the payments, how to make the payments more efficient for our customers. We're unique in that we provide netting capabilities to our banks. So when they send money and receive money, they don't have to lay out all the money that they're sending. They can actually net it off of the money that they're receiving. So they're not out the $2 trillion per day there, because at the end of the day, they're settling. They're almost always receiving as much as they're sending. So we have a liquidity ratio of about 27-1. So instead of the $27, you're only laying out $1 for $27 worth of volume. So that's something that we constantly work on to make sure it's efficient, and we do a lot of advanced analytics to ensure that that ratio continues. So again, this is how we've implemented. We have more. We've implemented this for one of our payment rails. This is our largest and most critical wire payments, but we're also looking for these same capabilities in our instant payments, and we expect to do that next year. We're going to start to look at some capabilities there, and that's it. I had there's some quotes here from some of the industry folks about the importance of ISO 20022. I think it's some of it is again, it's kind of an obscure standard for folks who are not in the industry. But I think it's a big change in how we will make payments in the future. And even if you don't notice it in your day-to-day business, almost every payment that you're making today on these payment rails will actually move across this new standard. So I'll pause here. And if there are any questions?
I have one question.
Sure.
On the audit structure data, I want to put the legal cases. You need every to run such the famous and analyze and find it.
Yeah. So when we put a search, so we have a requirement to search everything in the message. So both the structured and unstructured. So if they're, John Q. bad guy out of some, any town, Missouri, we have to look at that data both in the structured and unstructured and return that result. We have to be able to score that and make sure that the information that we're not getting false information. So we built a user interface. We're using the search syntax and logic within MarkLogic.
We also have stability.
Banks have themselves are subject to subpoenas. They're subject to compliance. They need to. Yes. Yeah. For anyone looking at a payment, they'll have to be able to, in order to find the payment, if they don't have some of these identifiers, they'll have to do a structured and unstructured search.
That's even though I saw out a lot more stuff than the twisted before, it's still not often.
Exactly. So
rules that document got that type of
right. So payment systems don't they take generations, 20, 30 years between major shifts in a payment format, for instance. And when we adopted ISO, not all the banks and not all the players were willing to put all the unstructured information in all their legacy systems into structured. That would have been too huge a lift. So in order to adopt it, there was some key information that had to be structured, but the standard allowed, there were two standard bodies, and they negotiated what was left unstructured. But each year, there is there'll be a new spec published that says more and more we're moving to structured. So the banks have to keep up and have to actually, they can't defer this forever. At some point, all the information will be structured. But we're in this period now where for many years, we'll have the mix.
Okay,
it's vital. Yeah. Just because it's structured or unstructured doesn't necessarily mean it's unimportant. It's a huge lift to take all their, a lot of mainframe, a lot of legacy data. Exactly. Perfect is the enemy of good here.
just wanted that complexity and the fact that it came to what you drive to find you can get to know.
So I think the formats changed so infrequently that in 2006, XML was the, hey, this is the future proof. Now we've moved on potentially, and there's other formats out there, but it was agreed in the banking industry that XML would satisfy the requirements to get off the proprietary. Probably I don't think we'll have to wait. There will be some new format, but it will take a very long time for all the banks and all the industry to agree on what's next after XML. So there's certainly lots of candidates out there, but for now, it's a significant lag to the new bleeding edge technologies.
And are there any products that was getting number 5 that handle a sub 20 or 20 or that still the zero?
So there are certain, I would say, vendors who specialize in payments and processing. So they have created their own adapters for ISO 20022, and they sell those products to the They can take they're taking a legacy format and they're converting it internally. They may be using their own, storage and technology, but a lot of these vendors are primarily looking at the format and making sure that, and they're selling those products to the banks and payment processors.
Well, when they're thought to say are they go just with the banks all build their own thing and it's just anyway, don't it somebody there.
So some of the banks implement it themselves. They have large technology organizations, they can implement it. Some of them rely on a vendor that's built to their legacy core systems. A lot of the core banking systems they don't want to touch, so they'll ask a vendor that built that for them to adapt it. And then there's third parties that will also come in and do an add-on. So there's a variety. Some of our banks are are moving to a completely new banking systems, and in that case, they have more control over building their own.
Do all the banks do it to install, or do they?
So the correspondent banking is really part of that. Is that small banks use larger banks' capabilities, but there's also there are parties like there are vendors like Jack Henry, FIS, Fiserv. They service a lot of the small banks, and so they'll build banking solutions that will have this.
Oh, so you say I can understand the bubble of the
Oh, a lot of them don't. A lot of small community banks and other banks, they rely on a vendor to support for them. Yes, they know that this has to happen. They have to pay for a vendor to make this happen, but they don't have a technology staff in some cases. Yeah, in terms of implementing, yes, and folks who sell to the bigger and smaller. So the greater the amount of data, the more information they can tell about their customers and so they can upsell. And so this richness of data that they didn't have before. So there was a lot of data because it went through so many hops. By the time they got something, it was pretty minimal. Now they've got a lot more data and a lot more information. So that competitively, they can see more, they can understand the buying and the selling and what actually is going on, the economic activity. So there is a competitive advantage. It improves the whole industry, but those who are early adopters also have that advantage.
That's right. It's just the adopting of lots and you can use.
So it's interesting, like as digital currencies, we provide US dollar transactions to the industry and to the banks. They also look at things like their own digital currencies, central bank digital currencies. So there's lots of solutions that are out there I would say sometimes solutions looking for a problem. We do have, the blockchain is one attempt to have this kind of a decentralized solution where everybody could see the transaction on the ledger. But there is a degree of opacity to a transaction by definition. You're only sharing, and once you share it, everybody can see it. So I think there's some solutions out there, some vendors who will have a blockchain solution where they can solve the visibility issue. Clearly the customer still owns their data. The banks are just using that to make the transactions and to improve the customer experience. But I think here, this is a much more, it's standardized. The blockchain is going to end up being a proprietary, format to what they're using. So, we've been hearing about this for a while. I think there's some advantages still from a centralized authority for payments. Cleve?
And that's it.
Yeah, so KYC becomes a lot easier if you know the information, all the information about a customer. So in order to make a wire payment, there's minimum information that is absolutely necessary to know about that customer. So you now have full entity information. Who are they? What bank are they with? Where is the transaction coming from? So the KYC parts of this become a lot easier. In many cases before, you would have to go and do research to look up and find out that information. And when you had a KYC error, that something that should happen in seconds or minutes can now take days, because you have to validate who the customer is. So there's a lot of KYC that becomes easier for the banks. Anti-money laundering regulations. There's quite a bit more, because now that we have a standard, we can also reference those transactions in a unique way. So it's not it's again, this research gets a lot more instantaneous than if something fails, then you can look at it immediately and repair it.
And the regulation.
More difficult? Impediment?
And the study is what.
Right. So a lot of this information, when it flows through, the participants have to, for instance, in a wire payment, you have to pass along all the information in order for it to be inspected. But you also have to make sure that the data that you're passing along is only visible to the ones who need to, if I have a compliance staff, they get to see it. But my operations team, they can't see that data. They're only seeing a piece of. So again, the technology has to be pretty sophisticated to be able to separate. You can't just, again, put rules in a relational database to say, oh, what can I see? What can't I see? There's potentially a lot of extra processing to filter out the data. It's kind of nice that, Mark Logic solution, type solution, makes it a lot easier to apply directly against the XML schema. Yeah, I think you were saying that, for the regulators have to have this information. They have to have it quickly. They can't wait. These, and I'll give the experience. So we have, when a bank closes, today, payments in the U.S. Between banks, the Fed is only open certain days of the week. It's only open on business days. So if a bank is going to fail, usually they choose a weekend to make that happen, so that people can't. There's no run on the bank. There's no, so they can orderly shut that down. But that's not going to last long. The Fed is, already making plans to go to what they call extended hours. We're also do the same thing, where we'll be doing, all payments throughout the weekend, We won't get to 24/7 immediately, but we'll be taking incremental steps to getting to 24/7. And in that case, the regulations you have to instantly react to a problem. If there's a systemic risk issue, the regulators, ourselves, we have to be able to respond immediately and understand what activity needs to be potentially curtailed.
You did get your thing.
Exactly. So a lot of these things are we have we do have a payment rail today, instant payments, TCH real time payments. It is 24/7. It's 1 million now, actually. Yeah. So instant payments, real time payments, FedNow is the Fed service. Those now you can do 24/7, and up to $1 million in payments. You can move money. So those are not those adoption rates are still going to take many years for it to reach the size of the ACH or wire market, but those are already providing some advantages, some use cases. One of the more important gig workers. If I'm an Uber driver and I want to get paid at the end of my shift, I don't want payroll to do a direct deposit that's 2 weeks later and I don't get it on a weekend. I want it literally 5 o'clock. I clock out my bank account. Uber uses a bank, and they will actually put it in your account when you sign off. So those kinds of use cases we are seeing in the real time payment space, mostly retail, mostly consumer, but that's the future.
You are still assignment.
I don't know. I have no idea.
Get it, man.
Yeah, there's the ecosystem is rich. There's lots of folks. Any other questions?
Go ahead.
So if you look at this picture on it's on both, but the processing is done by legacy systems surrounded by some microservices. What we do is we log every message into MarkLogic, and we provide that as a resiliency across all our data centers. We have multiple data centers, and that is the source of truth for the actual message that we sent and received. But the core legacy system is still processing the transaction. And then what we do is we take that MarkLogic database that's replicated across our data centers, and we move that at increments to our query side. And that's where things like the analytics and speed of search and operational analytics occur as well. But if customers want to see, if they're looking up on the left-hand side, they can look up their, they want to understand what payments they received, and they don't want to go through the legacy system. There is an option on the command side to also.
And the reason it's about the process of transaction was used in a step like that.
Exactly. So the legacy system.
It all needs a power.
That's right. So when we get a payment message that, as I said, was a magnitude larger than what we need, and XML is quite verbose, what our legacy system needs, it wants something that's very small that it can perform very quickly. So what we do is we actually separate, we zip all the non-critical payment information, and we send it through. But we're logging the full verbose version to MarkLogic.
Because that's still a lot of banks, so there I still like understand that.
Oh, absolutely. That's definitely happening. But I think it's more challenging for some of them because there's for us, we don't care. Mary is sending information to Joe. We don't care really who Mary and Joe are. We care about the amount, where it's going, which account to which account. The banks care about Mary and Joe. That's their customer. They need to find information in their database. They need more than we do. We only need 10 elements. Yeah, they benefit most from the rich data that's available.
the assistant.
to chop it off and that right. So this is going to continue to evolve, and the richness of the data is going to continue to enhance. It will become a competitive advantage for banks who can do it faster and better. All right. Well, thank you for the time. Really appreciate it. Okay.